Hi Algebra 2 students, this is Mrs. Vara. This video is the first video for lesson 6-6. So this is page 6 in your notes, but we're going to flip over and actually start on page 7. That exploration is not going to be part of the notes. So we're solving exponential equations. So different than 6-5, everything we look at now is going to be a solve, and it's going to be an equation. It's going to have an equal sign. And remember, solving means we want x equals a value. So this is an example of an exponential equation. So you notice you're going to have a base and an exponent, and your variable is going to be, like I like to say, stuck up here in your exponent. Okay, so we need to get that x down out of the exponent in order to solve for x. So a couple of things: it has an equal sign and the variable is an exponent. That's why we call them exponential equations, because the variable is an exponent. Okay, so this is a reminder, if the bases are the same, the exponents can be set equal to each other. So it's probably a reminder from the exploration, which we didn't do, but let's just think about this example. First of all, we have an equal sign. So we know everything over here is equal to everything over here. And the bases are already equal. 2 is equal to 2. So if this part is already equal to this part, then the exponents must also be equal, because everything over here is equal to everything over here. The 2's are already equal, so then we can set the exponents equal and solve for x. So this says if the bases are the same, the exponents can be set equal to each other. That's what I did up here. So the first thing you want to check is, step 1, are the bases the same? So these both have a base 3. 3 to the 2x equals 3 to the 4th. If the bases are the same, then step 2 is set the exponents equal to each other. So this would simply be 2x equals 4. And then we're going to solve this. It's an Algebra 1 equation. We're going to solve for x. We have 2 multiplied by x. To undo multiplication, we divide both sides by 2. 2 divided by 2 is 1. So we have 1x equals 4 divided by 2 is 2. And then if you think about checking this, if I put x equals 2 back into this original equation, I would have x to the, instead of 2 times x, 2 times 2. Is that equal to 3 to the 4th? Yes, it is, because 2 times 2 is 4. All right, let's look at another one. Step 1, check your bases. Are they the same? Yes, they both have a base 4. So then I can do step 2, which says set my exponents equal to each other. If my bases are the same, I can set my exponents equal. So 9n minus 2 equals 25. And then solve for, in this case, n. So I want to undo addition and subtraction first. I'm going to add 2 to both sides, and I'm going to get 9n equals 27. Undo multiplication by dividing. 9 divided by 9 is 1, so 1n equals 3. Okay, turn the page. This is a your turn. So I'm going to say, pause the video for these, and then come back and see how you did. So for that first one, you should have gotten x equals 9. And for the second one, minus 1, you're going to get a fraction for this one. That is okay. You should have gotten x equals 4/3, or you may have put that in your calculator. Okay. Now, example 3. They're getting trickier already. Same base, No, we have a base 4 and a base 16. Can you make the bases common? The answer in this one is yes. I'll show you how in a minute. Once the bases are common, then you set the exponents equal to each other. So what you want to do here is you want to think, it's a 4, I have a 4 and a base 16. So can I rewrite 16 as 4 to the something? So you want to take the bigger base and see if you can rewrite this bigger base so it matches the smaller base. So I'm just going to say, well, 4 to the second power is the same as 16. So I'm going to rewrite this 16 as 4 to the second power. The left side I'm going to keep exactly the way it was. So now all I did was, these two are completely equivalent, so all I did was rewrite 16 in a different form. But when I write it in this form, then my bases match. So now they both have a base 4. So I can go ahead and set my exponents equal to each other. 9x minus 2 equals 2. And then I can solve for x. Add 2 to both sides. 9x equals 4. Undo multiplication by dividing. 9 divided by 9 is 1. So 1x equals 4 over 9. Again, you can just leave it as a fraction. Simplify the fraction if you need to. Or if you want, if you prefer a decimal, you can divide it. And what do you get here? 0.44444. So I'll say, or x equals 0.44, repeating. Okay, so again, if your bases don't match, can you rewrite the bigger base to be the same as the smaller base? Let's see if we have another one here. Oh, well, before we do another one, we're gonna do this, what we call is a cheat sheet. That might help you solve problems when you have to make a common base. So if you look down this is all your base 2s, 2 to the second power, 2 to the third, 2 to the fourth, 2 to the fifth, and so on. So what we want to do is complete the rest of this. So we have 3 to the second, 3 to the third, 3 to the fourth is 81. All I'm doing is putting this right into my calculator. 3 to the fifth is 243. And 3 to the sixth is 729. And so on. I'm not going to put all that in this video. You get the idea. You can finish completing this table. And then it'll be helpful when we're solving some of these problems. Now this one is a your turn. So again, its bases are not common, so you have to change the bases to make them common. Pause the video and try this one. Okay, if you did this, hopefully you realized that 4 is the same as 2 to the second power. That's how I can get my common bases. And then I can just go ahead and solve for x. So add 6 to both sides. 4x equals 8. Divide by 4. X equals 2. Okay. This is just a little reminder, the exponent rule. When you have an exponent raised to another exponent, power to a power, we call this the power rule. What we do with those exponents is multiply them. So this would become 2 to the 12th. Exponent, another exponent, multiply. It gets big really fast, so you multiply. All right, example 5. Are the bases the same? No. Can you make the bases common? So this is where the cheat sheet might come in handy. I want to rewrite 9 as a base 3. So if I go back to my cheat sheet here and I go down this column with my 3's, I notice, well, there's 9 right there. 3 to the second power is the same as 9. So I'm just gonna write that over here to remind myself. So I can rewrite 9 as 3 to the second power. Now what you have to be careful of here is, I want you to wrap that up in parentheses. All we did was replace the 9 with the 3 to the second power. But the 9 already had this other exponent on it. So we have to include that also. And then on the left, 3 to the 5x, we're not doing anything to that. So I rewrote 9 as 3 to the second power. 9 already had an exponent, so I have to put that on there also. So you can see that those are equivalent. Now, before I set my exponents equal to each other, I'm going to remind myself that a power raised to another power means I have to multiply these. So I'm going to go ahead and set my exponents equal, but what this is going to look like is 2 times that entire quantity, 2x minus 1. So it's distributive property happening here. So I have to have that power of 2 here times this other exponent. So now when I get down here to solve, PEMDAS, or order of operations, tells me to do exponents first. So 2 times 2x is 4x. 2 times negative 1 is negative 2. Now I notice I have x's on both sides. I want all my x's on one side. So there's more x's over here. So I'm going to say I want all my x's on the left. So 4x and positive 4x and negative 4x make a 0. So over here I'm left with negative 2. Over here 5x minus 4x, those are like terms, so I can combine those and I just get 1x. So x equals negative 2. Okay, there's a lot happening in that one. I'm going to do this your turn with you because I think one more example would be good. So I think you guys all know that 5 to the second power equals 25. So I can write 25. So I'm rewriting 25 as 5 to the second power. 25 already had an exponent on it, so I'm going to include that also. So all I did in this step was rewrite 25 as 5 to the second power. The left side over here, just copy that. That's a copy job. You don't need to do anything to that. Now this power to a power means I have to multiply. So I'm going to have 2 times 2x minus 1 equals 2x. And again, once I make those bases common, I can set my exponents equal to each other. Okay, now I'll let you go ahead and finish solving that. So pause the video and finish solving that. So if you solved that, you should have had now this one, I have more x's over here, so I think I'm going to do minus 2x from both sides here. I'm going to work up here. On the left, I'm going to have 0. That's okay. 4x minus 2x is 2x minus 2. Now I'm going to add 2 to both sides. 0 plus 2 is 2 equals 2x. These add to 0. Divide by 2. So x equals 1. Okay, try this one on your own, and then I think I am going to end this video right here.